Wow, yeah, welcome from West Africa. Great to see everyone here. I'm gonna start sharing my slide deck, and we'll get going. We do have share my screen. We do have some. We'll have people trickle in, and hopefully we won't have to do a whole lot of repeating or anything like that. I will go through the agenda and let me share my screen, and then let's see. So. Let me make a couple of like kind of housekeeping notes. After we're done here, we're going to share out the slide deck and a survey about how we did today, what you got out of it, what you wished you got out of it that you didn't, any of that, anything we could improve or keep doing, any of that. So you get a copy of the slide deck. This will be posted. We're recording it, a video of this, and it'll be posted to YouTube probably later today as well. And at the end of the day, we're going to have a set of links that Vaughn will share out in case anyone missed anything along the way. And by the way, Vaughn is here helping me today to take care of any chat I might miss, anything that maybe I'll miss while I'm going through slides. Be here to help out and post links along the way too. Okay, let's dive in. Let me move this video window because it's going to be in my way. All right. Okay, so welcome on this Saturday, late in April, to our introduction to LangChain. It's intended to be a fairly easy dive into LangChain. Nothing too critical. We will touch on a couple of maybe more advanced aspects and things that you can do with LangChain, but we won't get too deep. And we're also going to use another tool or two that I will mention, but I won't get real deep into. And those may be topics for future classes. So make sure that if you found us through registered through Eventbrite, that you save IntegrateDetroit so that you get notified about future classes as they come up. We try to do one once a month. So we'll be looking for another one actually from Vaughn next month. And then we're still a little bit to be determined for June. Maybe another LangChain class, maybe something else related to React or Next.js, or we're just figuring that out still. Okay, so let me tell you a little bit about myself. I'm a senior software engineer. My name is Joe Colburn. I don't know why my name is on here twice. That's what I get for copy and paste from another slide deck that I had. So I'm a AI enthusiast. I've been really kind of diving into AI. I wouldn't say anyone truly is a guru. Maybe a few people. But I'm not anywhere close to that. But I'm definitely an enthusiast, and I like to dive into anything new with AI and discover what is useful. I'm a Google Sheets tinkerer. If you can do it in Google Sheets, I will try. I did build a working copy of Wordle in Google Sheets. Uh, so that tells you how much I nerd out there. And then I'm an AZ native with an asterisk. I wasn't born there, but I grew up there most of my life, and I'm a Detroit transplant twice. I've moved out here 2 times, and I'm here for good now, I think. I'm a dog dad to 2 dogs. I wish I had their picture up here, but you can always ask me and I'll share it on LinkedIn or something. And I'm an amateur astrophotographer. I like to tinker with that as well. Um, Enough about me. Let me get into our agenda. Let me move a couple things around so I can see and be more efficient while I work here. Okay. So here's our outline for the day. We'll talk about the problem that we're solving with AI. And with the use of AI APIs. What is LangChain? We'll kind of get into a short description of it and how it can help. A note about Streamlit, and that's only really in here because we're using Streamlit to simplify things. So I'm gonna do like a one slide, half slide intro on what Streamlit does to help us kind of work faster through this class in general with proof of concepts. And then we'll search for some other things like it, and then what's missing from what you know. That's from a different slide actually. Anyway, so let's talk about the problem that we're solving, right? LLMs, large language models, they are stateless by default. So what that means is that we've got a request that we make via an API, via like OpenAI's API, for example. You make a request. If you make that request and you say the prompt that you send it is, my name is Joe, then it may respond and say, hey, good to meet you and all that, whatever. The next prompt that you send is a completely separate prompt with no context to the first prompt or link or way of knowing what you sent before. So when you send the next prompt and you say, what is my name? It's going to obviously say, I have no idea what your name is. I've never met you, and I have no, it actually gives something about, I don't collect your personal information, so I don't have that in front of me. So that's kind of the problem that we're solving, right? If you use an LLM via an API, you lose that context that comes naturally with something like ChatGPT, where they have built that outside of the API for you. So, chat applications add that state and they chain the requests together for their context so that it feels a little bit seamless. However, if you look at ChatGPT, especially if you've used early versions of it, you may have recognized that in a long-running chat, and this is more evident with something like code, it forgets things. It loses some of that context. And what happens is, and we'll get into tokens and token length and all of that later, but essentially the way that ChatGPT solves the problem of context is they take previous messages or parts of them and add that back into your new request so that it has the information from before plus the new request you're making. The problem with that is if you've looked at the OpenAI APIs and other ones, there's token limits, which means that essentially is a short way of saying it is you have a limited amount of what you can send and get back. And that puts a ceiling on how much context potentially you can send. So you have to deal with that as part of what you're building out. Let me open up chat just so I can see it, although I'm not going to be paying 100% attention to chat, which is one of the things Vaughn's helping with. Okay, so that's the problem, and that's kind of how ChatGPT solves it, and that's kind of how we're going to solve it today in a simplified form. So we will create a custom chat script that that is going to require us to add state and not necessarily chaining. We don't have to chain requests, but we're going to add previous requests to that chat state. And there's a few different ways to do that we'll go through. So what is LangChain? LangChain is a framework that's designed to simplify the creation of applications using large language models. So it's essentially a tool set, right? I've built a chat application that I had a custom need for it to be able to build a custom chat that wasn't ChatGPT, but acted like it around OpenAI's models. And in doing so, before I realized LangChain existed really, I had this problem that I had to solve with the context. And to do that, I had to learn about vector databases and some kind of more complex things that were not my primary focus. They were great to learn, but they weren't my primary focus, and they really distracted me from the thing that I was building because I had to learn additional technologies to get familiar with how to fix those problems. LangChain does a lot of that for you. There are cases where you may look at LangChain and find that it's not the right case for what you're doing. But for the cases where it is useful, it's extremely useful because it abstracts away a lot of that extra technology and deeper things like vector DBs that you might not want to focus on while you're just building a chat app. So some of the things it includes, and this is not an all-inclusive list, but some things that stand out to me. LLM integrations. So it provides a framework through which you can switch LLMs and use different models and all of that a little bit more seamlessly. And it integrates with quite a few of them. And so, I mean, you'll see, I think, Grok and of course OpenAI and I think Llama's in there. Like there's a lot of support for different integrations. They offer prompt templates. So if you ever done the practice of pre-prompting, where you say something like, you are an extremely experienced software engineer and you focus on test-driven development, and everything that you give me today will provide tests first and be in this kind of a format. Those kind of pre-prompts go a long way to getting what you want on a first try. Prompt templates help with that, especially when you're chaining things. You can use a prompt template that can take the response from one thing and give it to another. We won't go into that deeply, but it's something to check out if you start looking a little deeper into LangChain. Then there's also output parsing. I probably shouldn't go through all of these in too much detail. And then conversation chaining, which I mentioned a little bit with prompt templates, where you can chain things, but also conversation chaining in the aspect of what we're doing today with memory. Okay. This is a kind of aside about Streamlit. Streamlit is something that I found when I was going through a tutorial on, I don't even remember what it was at the time. And I will say, when you see someone doing a tutorial and they're using a tool that you've never seen that you think is great and useful, that could be useful to you, make a note of what that tool is or ask them if it's not obvious. Always opportunities to learn. Just look for those and make use of them. But so Streamlit, I came across, and I had developed other POCs before, like with a chatbot or with a somewhat agentic application where I tell ChatGPT to do something, and then it determines the next steps and does them for me. But testing all of that was a little difficult, not difficult, but a little less straightforward to read and to understand, doing it all in the command line. And I still use the command line, but Streamlit provides a graphical user interface without any of the knowledge or work required to do a graphical user interface. So this is a screenshot that I stole from their website. Not really a good example of what we're using it for today, but we'll see it. But it is a good example of just kind of how robust it is. You can send it a piece of data and it will display it in the most likely format, or you can be more specific about how to display data, and get things like tables and input forms and output and graphs and all sorts of things from it. So it's a good tool to have in your toolbox. So I wanted to mention it. And also make sure I say up front what it is, because otherwise it might be a little confusing to see that in the code, since it's not LangChain, but just another tool that we're using. Okay, so let's move on to our first bit of code. And I should preface this too by saying that we'll go through the code in slides, and then we'll also go through, and you will get the slide deck later, so you'll have access to all this code just right here in the slides. But we'll also go through and drop to the IDE, and I'll show these things actually working versus, just seeing them in the slides. Feel free to try and write some of this code along the way as we go. And just know that if I go a little bit quicker through the slides, I probably won't go that fast through it. We have plenty of time. That we will be digging into the code a little bit in the IDE later as well, and we'll have plenty of time to stop and deal with any questions or explain some things that might need more explaining. Okay. So the first thing that we have in here is the installation of the LangChain OpenAI library. And if you've used OpenAI's API before in Python, then this looks fairly familiar, except this one's LangChain's tools in OpenAI. And the reason we're doing that is because LangChain is going to handle everything for you, and it does it in a similar way where you can set up an environment variable with your API key. So you'll set that up in your local environment, and then it can use that. It reads it in here, and can use that to connect. But let's go through each line of code. So first thing that you have to do, in the top, we have our command that you run on the command line, and that's to install LangChain OpenAI. And then we'll import OS, which you shouldn't have to do a pip install or anything for that, if I recall correctly. And then from LangChain OpenAI, we'll import OpenAI. This is the very simple example of just connecting with OpenAI. So once that is imported, then the next line of code here is to get the key from your environment variable. And if you don't know how to set that environment variable, we can go through that as well. But we'll get to that a little bit more when we get into the IDE side. When we drop down to the IDE, I can show that if we need to. And then, so now you have your OpenAI key stored in this variable. And then the next step here is to set up your LLM connection. And that uses OpenAI that we imported and passes along your OpenAI key. And then we get our response by passing a prompt. In this case, we're hard coding what is 2 + 2, just a super simple prompt here, to the LLM that we set up, and then we print the response. And I should have, well, we'll go through this when we drop down to the IDE in after some future slides. I should have printed out what the response looks like. We'll see some of it, but this basically just prints out what the LLM's answer is, the response to what is 2 + 2. Okay, so that's step one, right? Setting it up, make sure that you can connect to the API. I like to do this in small steps because if you've ever copied a big block of code where someone's completed the whole thing, like from a class or from some example, and then it doesn't work, then you're sometimes trying to figure out, which part of it is broken. And this is good because it gives you small chunks to read and understand, so you get familiar with the code. Even if you do copy and paste it, I prefer to type it out because I definitely get more out of it learning wise. But then also, if you do have problems as you go along, you'll see that you'll have much easier time trying to understand what those problems are. I see a question in chat. What OpenAI LLM model will be used by default? I believe it's using 3.5 or 3.5 Turbo by default. I don't have a definitive answer, but I believe it is one of those. Um, and the OpenAI documentation would have actually the LangChain OpenAI documentation will have a little bit more detail on that, I think. I believe it's one of those. I didn't honestly get into that too much because what we're doing with it here is simplified, but there is a nod to in a future slide here to digging a little bit more on how some of these tools work in LangChain stocks. Okay, so let's move on to step 2, right? So step 1 is we connect to the API and we get a response back. Also, by the way, so to the point of your question, the call that you make to invoke has other parameters on it here. Let me go back. You can add parameters and specify what model you want right here after the prompt. I believe it's after the prompt. Okay, so step 2, Streamlit for more sanity. And then, I kind of described what Streamlit does. Essentially, Streamlit makes it so you don't have to worry about all the UI and you can get things that are easier to read. Once you start getting into conversational history and trying to spit that back out so you can see what was sent and what was received, it gets kind of ugly in a command line. It's hard to read. And it makes it a lot easier if you can see it in a GUI kind of format in the web browser. So Streamlit is simple enough to install. Excuse me for a second. I have a really dry throat today, so I'm gonna grab a cough drop so I'm not maybe a little more understandable as we go. Okay, so Streamlit gets installed. I put kind of 2 commands on one line here. You can, if you're not familiar with this, you can separate commands with and. And what that does is it completes the first command and then the second command after it. Yeah, and I see a comment too about pip not found. Yeah, you can install Python and pip. If you don't have that installed, you'll need that to be able to do any of this code for sure. Thanks, Vaughn. So the way you would install Streamlit, and it will vary depending on your, it may vary a little bit depending on your computer, what your setup is. But Streamlit's website has some description on how to do this as well. But you install it with pip install Streamlit. So if you're on a Mac or Linux computer, that's how you would do that. And then Streamlit hello is just a command to test it out. And it actually pulls up a web page. So Streamlit hosts a really lightweight web server locally for you, and it'll pull that up and it'll show you some examples of what it can do. So that's how you would install it. I want to go into a question in the chat real quick too, just to make sure we can help with anything in case someone's getting left behind a little bit. If it says pip not command, try pip 3. I have seen that happen before. Another option might be to try Python space -m space pip instead of pip as a command solo. I don't know that any of those will definitely work, but those are some things that you could try out if you're running into that problem. Okay, so in our second step here, we have the same code, but where we have the yellow arrows on this slide, describe some of the things that we're adding here. So in here, we're going to import Streamlit as st. So as st, if you're not familiar with Python, that's just giving it a short name, so I don't have to type Streamlit the whole time. And then at the bottom of this, so everything else is the same. And at the bottom, we're doing is st.write. So that's basically saying use the Streamlit package and invoke the write method to write the response out. So instead of, let me go back a slide, instead of print response, we're going to st write the response. And what that does is that will print it to the web browser page. So, and then this gets run in a different way. So when you run the chat application without Streamlit, it's just like any other Python script you would run. Python space and then the name of the script. Mine is called chat.py. Actually, mine's called class.py. I forgot to update this, but that's how you would run it with Python. With Streamlit, you can run the command Streamlit, or like I was mentioning with the pip3 command, you can run the Streamlit module with Python. I believe that's what the M stands for. Python space -m space Streamlit space chat.py. So you could try it as just Streamlit chat.py. But if that doesn't work, do Python space -m. And I think there's a way to fix that with a path setting in your computer. But I won't get into that. I just want to show how to do it if it doesn't work with just the Streamlit command. So in this step 2, that's all we did is we added the Streamlit package and we swapped out the print, the normal Python print, with an st-write. And then the difference here also is how we run it. We're running it through Streamlit so that it shows up in a web page. And then the next one, you kind of get an idea of what Streamlit looks like. But let's go through the code first on this one and see what else we're adding here. So here now, instead, we don't want to hard code what is 2 + 2. That's not very useful. So let's actually ask for a prompt. This is another area where Streamlit is useful because now we're getting in a user interaction, and a user interface that looks nice or nice enough is certainly better than just doing it all in the command line. So what we're adding here is we're changing the input that we're sending to be in an input_text variable. And to do that, we use another Streamlit method called st_text_input. So again, we're getting a little bit into Streamlit, but that's just so that we can get to how we're going to chain the responses. So we will get there, I promise. So we give it a label prompt, and then that's going to store whatever you type in that prompt box into this variable input text. And then these next 3 lines, we want to check that we have input text. If you don't do this if conditional, and you just do the response like before and then print it out, what ends up happening is that it will give you some random response before it ever takes your prompt into consideration. Because this is just a script, it's going to run each line of code, right? So what happens is it puts a prompt out there and then immediately calls the LLM. But if we put a conditional here, then what we get is when the page first renders, we have a check for the input text. Nothing's been typed in yet, so it doesn't do these things. And then after you type that in and hit enter, then it's going to go through its normal process, invoke the LLM with your input, and then write out the response. And here's an example. I don't know if it's easy enough to read, but it says prompt. And I prompted, give me a random color and no other text, because otherwise it'll tell me the whole history of magenta. And then it gives me a color back magenta. So that's how we get input in here. Vaughn, you have your hand up.
Yeah, I was just curious. So on that first line that you changed, where you set the variable input text there,
Yeah.
is that given that you're passing it a label, will that always satisfy that if condition or not necessarily?
No, the label that's passed is the input to the text input method, and that tells it what to display up here.
I see. Okay.
Yeah. Um, and there's if you look at Streamlit's documentation, there's all sorts of crazy stuff you can do. I didn't I won't get into any of it, and honestly, I don't know a lot of it. Because I use Streamlit as um I'm going the wrong way. I use Streamlit for exactly what it says here, more sanity, just to simplify the development. Because I don't want to be looking at stuff in the command line, and I want to make input and output a little easier. So,
Sure.
yep.
All right.
But yeah,
Understood.
that's just the feeding Streamlit what I want the prompt to look like. So that's a simplified example of how you can use Streamlit to get the input and handle output with input and write. And there's other input types, right? There's sliders. There's an application I'm working on where I'm using Streamlit sliders to move a camera around and things like that. Okay, so let's go on to the meat of it, right? We're in 3, 4, yeah. So now we're gonna add some memory, and this is where it gets a little bit more complicated, but also where we're getting to what we're actually here for today, right? Took us a second, but we're here. So now we're gonna add the ellipsis up here is because the code's getting a little long. I didn't want to repeat extra code that you've already seen. So these are the previous imports. And then after those imports, we're gonna add 2 more. So we're still importing OS and Streamlit. And then we're gonna import also LangChain.chains. From that, we're going to import conversation chain. And that's what we're going to use to handle our conversation and chain it all together. And then from LangChain.memory, we're going to import conversation buffer memory. And I will go into, on the next slide, we're going to get into some different styles of conversation buffering that can happen, different ways to handle memory with LangChain. This is the one that we chose, the one that we used as conversation buffer memory specifically. And you'll see in a minute, on the next slide in a few minutes, you'll see different reasons why you might use different types of buffer memory. Um, so the rest of this code we had before, or the next 3 lines, I should say. And then the next line after that is this whole section. This arrow kind of points to this section of code, which is so now we are looking to see if conversation exists in session state from Streamlit. So Streamlit, because it's acting as a lightweight server, is where we want to store a session. If we didn't use Streamlit, and I want to make sure I point this out because maybe you don't want to use Streamlit. Maybe you build this with Streamlit and then you want to port over to using your own customized UI in an actual web server. st.session_state is just another tool in Streamlit that allows us to store session in its lightweight server that we're using to display this through a web browser. So if you port over, don't use Streamlit at all. This is kind of important. You want to keep this session somewhere. You need to store this conversation somewhere, whether that's local memory or in a database or something else. Okay. So what we do first is we check if the conversation's in the session state. And if it's not, then if it's not in session state, then we set the conversation as a new variable in session state. And what we give that variable is this conversation chain. So we're creating a new conversation chain, and we're passing it our LLM that we already set up, which is in this case OpenAI. And then we're passing it what we want for memory. So in our case, we want to use conversation buffer memory, and that tells LangChain's tools to take whatever we do with our conversation and store it in a conversation buffer memory as our type of memory, that how we want to store it. And we'll get into the details in the next slide in a minute. The next slide is really kind of pointing us out to a different website where I want to go through some of how these details work. So that sets up the conversation, right? So now we have an empty conversation. And then after that, we're going to do our previous check that we already had for input text. And if we have that input text, then we're going to send it like we did before, only this time for the response, we're sending the input to the conversation. So now LangChain, instead of just telling LangChain to directly send your input text to the LLM and get a response back, now we're doing it through this conversation chain, where LangChain does all of the behind the scenes work to say, were there previous conversations that we already had in this chain? Do we have to summarize those? How do we summarize it based on which conversation buffer or memory type we chose? And it does all the work of putting all that together, kind of behind the scenes, and then it sends out the request to the LLM and gets a response back that we store here. And then we write the response like normal. And what that looks like is this screenshot here, where we can see, excuse me, we can see that we've sent a prompt, and that the prompt is, do you remember my name? So what you don't see here is there was a previous conversation, and you kind of see it in the history that's printed out here. So when we do a ST write, we're seeing the whole history, right? So we see in the history previously, I said, hi, I'm Joe, and it responded. The AI responded, hi, Joe, it's nice to meet you, etc. And then I gave it a new prompt, do you remember my name? And it has all this history, which is just these two, this one prompt and response. And then it generates a new response, yes, your name is Joe. So it has a memory of that because it has the history that got passed along. So that's kind of in a nutshell how you would add the memory to the conversation. Let's go into the memory options a little bit so we can get a better understanding of that, because that was kind of glossed over, just add 2 lines of code, 3 lines of code, and you get conversation memory. But here's how it works a little bit. So let's talk first about token usage in LLMs. Some of you may be familiar with this, so bear with me for a second if you are already familiar. But in an LLM request, you have a token limit. We touched on this a little bit early in the presentation or in this class. But the token usage is broken down. Well, I'm going to read what ChatGPT gave back to me, actually. Tokens in LLM usage are counted by breaking down the text into individual words, punctuation marks, and other elements, with each of these counted as 1 token. So that's not to say that a word is 1 token, like a word could be 2 tokens. But generally speaking, I think it's about 1.2. There's some kind of loose math that you can put around kind of trying to calculate how many tokens you would use. But generally speaking, you figure if you got about 100 words, you're probably looking at 110, 120 tokens, something like that. So the token count matters, right? Because especially when you're talking about a conversation, if you're having a conversation with an LLM and it lasts 20, 30 minutes, an hour, you're going to be just racking up tons of tokens, and they build up and they build up. So if you have this conversation history, and the cheap way to do it is to just take all of the things that you sent and all the responses and mash them all together in one large text and send those back in your new prompt with whatever your new prompt is. The problem with that, obviously, is that you run out of space, right? If you think of your token limitation on an API request as a notepad, small notepad of paper, you can only, and you have to write in the same size font through the whole notepad, you can only write so much, right? You're going to hit a limit. So you have to find ways to use kind of a shorthand, a digital shorthand for all of the history. And sometimes you don't. Sometimes the full history is fine, and it depends on your strategy. So let's it depends on your use case. So let's look at the strategies that exist. There's a really good Pinecone, by the way, is another tool that that's actually what I used previously to store conversation history in VectorDB. And they know a lot about how this works. So they did a really good article here about, and Vaughn linked to this in chat, about how LangChain handles conversational memory and the different kind of methods that are involved. So let me go through a couple of them. We won't get into every single one. But there's some graphs along the way, and I'll do a little skipping forward to some of these at one point here, that are helpful to get a better understanding of the differences. So conversation buffer memory is the one that we're using today. And it's like it says here, it's the most straightforward. It takes the raw input and sends in its raw form as history, a history parameter. But and we'll get into the graphs in a minute, so I'm not going to go through all of this. There's a lot to read here, and I invite you, I implore you actually to read through this whole thing if you really want a good understanding of how these work. But I won't do it right now in the interest of time. There's also conversation summary memory, and that's a little bit different in that it doesn't send the whole history back. It as the name would suggest, it summarizes a conversation before it's passed to history, right? So you don't get everything. And there's a question here: is it possible to exceed the max tokens for context if your memory is large enough? What happens if you send, at least in my previous experience, if you send something too large, you will get an error back if what you send is larger than the max allowed tokens. I believe you get an error back. If what you send is close enough that it's almost at the very maximum, and your response is large enough that it exceeds the maximum token count because it's your request and response, I believe it cuts off the response. So either way, it's important to get a good feel for your token count. Like normally my code would include an output of what the actual token count is, and in a conversational history scenario like this, I would also be outputting the full history, like how much the token count increased with each chat. So I get a good idea of what kind of limitations I'm looking at. If I expect the conversation to have, let's say, 30 messages, then I can kind of do some rough napkin math on what I think a token count might look like. But as we'll see with some of these other things, right? We have buffer memory, which stores the whole history. We have summary memory, which summarizes it. And we'll look at an example of that real quick to kind of understand what it does. So it takes this output and kind of summarizes it into something smaller. And then, yeah, I don't know if that's the example I was hoping to show. Anyway, it summarizes it. It's not going to use every word from your previous history. It's going to shrink that down a little bit. And then it continues to do that through each request so that maybe some things are duplicated. It's not going to have all that duplicate stuff in there eating up tokens. And here's the this is, I think, a little bit older article. We're seeing a token limit of 4097, but and the token limits have gone up quite a bit with newer models, which is great, but it doesn't solve the problem of a token limit. It just makes it less painful or less immediate. But as an example, like conversation buffer memory, you can see as the conversation goes along, the token count just goes up and up and up per call. These are per call token counts, right? So your first token count is really small. You only have one request, right? When you're five chats in, now you've got 5 calls in. Now you've got a little bit of history, and it's growing and growing. And at some point, you're going to hit this token limit if you use just conversation buffer memory. So for small chats, it's fine, especially with larger models that I should say higher token count models, because it's going to be a long time before you hit that. And maybe in whatever your use case is, maybe it's never going to hit that. And it might be more important to have the complete raw conversation in the buffer memory than a summary. It'll be more reliable potentially. It has the exact words, so you could say things like, repeat back exactly what I said 47 messages ago. You can't do the same kind of thing with conversation summary memory because it only has a summary. If you ask it to repeat back exactly what you said, you may not get that. So it really does depend on your use case, your particular needs. If you need the exact conversation history, but for smaller conversations, conversation buffer memory may be better. If you don't need that exactness, but you do need a larger memory for conversation summary memory might be better. And there's a clarification, maybe question here. For small conversations, it's better to store the history ourselves and pass it as context to the LLM, or can we simply use a chat LLM model? Yes. Yeah, I would say so. For small conversations, you can, I wouldn't say it's better to store the conversation history yourselves and pass it, because you're still having to do the work of putting the conversation together. Is it really a lot more code? Probably not. Than doing LangChain, adding it through LangChain. Probably not. And then I'm not sure about the second part about can we simply use LLM model? If you mean ChatGPT, one of the reasons for building your custom, there's many reasons you can have for building a custom chat. One could be to be white labeling it through your own website. One could be to the reason that I built it is if I'm sending it things that I want to make sure I have some kind of a filter, a guardrail put in place. I can build that into my own code before anything ever gets sent to an LLM. So I know that maybe I'm not sending client names or passwords or anything like that. I mean, I probably wouldn't be pasting a password into a ChatGPT anyway, but to be able to build a guardrail around a chat experience is one reason that you might build a customized chat interface. And I would say there's other advantages to something like LangChain that also, even if it's not just for the conversation history, there's some other tools that you can get out of it. But like I said at the beginning of the class too, there's certainly going to be times where you fire up your Python code and say, all right, do I need LangChain? And if you look at it and look at what it has to offer, and it's not giving you an advantage, then that will happen sometimes too. And just skip it and use the tools that matter for the use case. Okay, so that's a great couple of questions there. Feel free to keep throwing questions out. I'd love to make sure that you'll get the most out of this class, and we have the time for the questions built in. So anyway, this graph here does show a pretty good kind of, it's not exact, of course, but this is a good idea of kind of how conversation summary memory works, where you'll see that instead of just going a straight angle up, we get kind of this pattern of a lesser incline, and sometimes there's big bumps, right? Like, so if you see above where there's 15, conversation number or chat number 15, request number 15, right before that, there's this big bump, and that's kind of representative on this graph of maybe in chat 13, request 13, we had a whole bunch of new words, and maybe I pasted a bunch of code and I wasn't pasting any code before. And so this is all like a whole bunch of new context that's hard to summarize. And then maybe there was some duplicate before that, or I'd said, hey, forget about all that code I wrote. So conversation summary kind of lessens your token count by doing the summary. And then there's I don't know if we'll get, there's not a whole lot here. So conversation buffer window memory is another way of doing it. It adds a window to the memory, so we only keep a number of the past interactions before forgetting the rest. So we can say, give me just the last like 7 requests. I don't care about anything past the last 7, right? I can't think of a lot of use cases for that, but I can think of, maybe 1 or 2 where you would want to do that. And then here's another graph they provided which shows kind of a little bit more of an idea of how that might come into play. So this one, they actually have 2 conversation buffer window memories, one with a 6, so that's the just keep the last 6, and one with a 12. So you can kind of see like how this works when you have a lower count, you just keep that token count way lower. And then if you have a higher one. And one of the reasons for that is if you truly don't need that far back of a history, then you're saving on the throughput of those API calls too. So every API call, you're sending data back and forth. And as you send more data back and forth, more text, more history, it may not be a lot, but it can add up, especially if you're trying to build a highly scalable performant application. You end up thinking more about things like, am I sending, these extra bits? Smaller applications, not quite as much of a concern. And the speed is kind of negligible. And then there's conversation summary buffer memory, which is kind of a mix. And you see a graph here that kind of shows how that works too. There's summary memory, there's buffer memory up at the top, which uses everything. And then summary buffering memory, you can give it a max token limit and do some things like that as you can see from the graph, it starts getting a little bit less predictable the more complex some of these things, some of these patterns are. Conversation buffer memory is what I defaulted to for this class to show as an example, because it shows the whole memory. And if you're not too worried about, if you're just building something simple, a proof of concept, it's the easiest way to prove out that you're getting the full history back, and to test that it's working well, and it's just easier to work with. The rest of these are just good to have in your back pocket to remember. And then there's additional things that you can look through here. But I'll stop going through that, and we'll get back into this guy here. Um, okay, so the next thing is to see some working code. We're about an hour in, so we're running, I think, a little bit ahead of time. Let's stop for a second. Does anyone have, excuse me, does anyone have any additional questions before we go through and watch the code work? And while we're watching the code work, we can also address any additional questions if someone's having problems, if you're already writing the code. So we'll start getting into the code, but if you're typing up questions, we'll definitely keep typing them. We'll stop, and you can come off mute too. I believe we have that ability if you want to come off mute, if you have a question as well. Okay, so let's see some code working. I'm actually going to switch over now to my IDE, and so I've set it up. I actually have all my code in one file here just to make it kind of easy for this class, so that we can go through those same steps that we showed in the slide deck. So ignore my squiggly lines here. I don't know why it's saying it can't find it, but it's there. So for this, I'll show it here, but then when I run after the first step, when I run it, it's going to pop open a window. So we'll be doing a little switching back and forth. I'll try not to go too fast for it, and we have a little bit of time. So here's our first example that we showed before. And if I run that on the command line, let me go to terminal instead. There we go. Let me run Python class.py. And so in this first one, this is what I was describing before. And if anyone can't read it, I try to make the font big enough, but let me know. This is what we get back, right? This is just what's being printed out is the response. So if you recall, this is the first step was just connecting to OpenAI. Oh, and let's just talk about this real quick too, right? So if you haven't set an environment variable, you have an API key that you get from whichever API you're implementing. LangChain has different ones you can implement and work with. But in OpenAI, you would go into your OpenAI API dashboard and get your API key, and then you would set it with something like this. We would say export. Forgot for a second there. Export, and then whatever the variable name is. So it's like API key. In my case, I don't want to overwrite mine, but it's ChatGPT API key, which is a bad name for it because it's not really ChatGPT, but that's what I named it a long time ago. And then you would say equals, and then whatever your API key is, you would paste it there. And then you can test that it wrote properly by doing this. Echo it out with a $sign in front of it, and you can see that it's set properly. So that's how you set your local variable if you need to do that. And if you put that in if you're in Linux, you can put that in your shell's configuration file, and it'll run every time you log in, so you don't have to do that every time you log in. That's really kind of a topic for another time, but anyway, so this is our first example where we're just connecting to OpenAI, sending it a prompt and printing a response back. Yeah, that's a great call out. Amin, is it Amin?
Yeah, I mean,
Yeah, I'm sorry?
yeah, you got it. I mean, thank you.
Okay, great. Thank you. Yeah, you can use .env file, which is certainly handy, more portable, or you can use just local environment variables. Either way works. The real important part to note is that you never obviously put your API key in the code. You're going to check that code in and share that code with people. Other people might see it. You never put your API key in the code. So as long as you have it in an environment variable or in a environment file or some other means, there's other means to do it that are not in the code. Yes, if you have it in an environment file, .env file, always put that in your .getignore every time. Okay, so that's our first example, right? We have, and I'm going to shrink this down now because we've already seen the output of the first run. So I'm just going to comment this guy out. And I'm going to uncomment step 2, where if you recall, in step 2, we added Streamlit here. So we're adding the Streamlit package so we can make use of it. And then we're also in step 2, we're swapping out the print for st.write. And we'll see what that looks like, but I'm actually going to go off book for a second and just run it normal and see what happens, right? So we get this warning because we ran this not in the way that it's intended, and it actually tells us what we should do is run Streamlit run class py. But we're actually, for some reason, I don't have the command working properly on mine. I didn't bother to fix it yet. So I'm gonna do it this way. I'm gonna run it through the module. Streamlit Python-m Streamlit. And then we tell it what to do. We're gonna run class.py. And now this is going to run it through Streamlit as I described. And what you'll see is this window will go away because it's going to pop the browser window into the foreground with a page open. And it put it in my other browser. Hold on. Let me drag it down here. I did not expect that. Okay, so we're actually, it's giving us the same response. All we're doing is printing the response. There's no input yet. And then what we end up with is our output in a Streamlit format, and Streamlit has these other things you can rerun it and stuff like that. But this is an example of just swapping over to Streamlit to print out the output in a more readable format. Okay, so if we go back, let me see if I close this and run it. Oh, by the way, if you close your script, eventually this will say connecting. And then it'll pop up a thing saying it failed to connect because it's constantly watching your code. It's a lightweight server and it constantly watches your code for changes. So what I did here to crash it and restart it, you don't have to do that. And I'll show that in a second. But I'm running it again just to see if it popped up in the right window, which it did. Okay. So anyway, this is what that looks like. I'm going to go back to the code. I'm going to leave this running. And I'm going to comment this out. And we're going to go into the next bit here, step 3. And if you recall, in step 3, we kept these 2 imports, these 3 imports. And then we kept these, right? But the new thing we added is the input text input prompt. And we can see actually there's additional things you can do, like put a value in there. So let's say I'm doing some testing and I don't want to type this every time I get into Streamlit. I could do that, right? So yeah, why not? Let's put that in there and see how it works. And then we added this check for input text. You know, and I told you what it does. Python indentation matters. I told you what it does if we don't check for it, and we can see that here, right? If we rerun this, what happens is it's already looking at what's in the prompt and running the call to OpenAI. And we don't want that. And a clearer example of that is if I take this guy back out, right? Save it, it's going to rerun. Oh, wait. I think I have to tell it always, yeah, always rerun. if you tell, excuse me, if you tell Streamlit to always rerun, it's going to always rerun whenever your code changes. So what happened here is I don't even have a prompt yet, and it's just giving me a random answer. I don't know what this is about, but it's just a random factoid or maybe hallucination that it came up with. So let's just undo some of those changes, right? Let's keep that. Actually, we've already seen we don't. So let's keep our check for input text, and we can see that it's first going to check for that, and then it's going to invoke only after it checks for that. So I'll save the file. It reran. Now we have a prompt, but nothing's happened yet. So now I can say, "Hi, I'm Joe." There is one tricky thing with Streamlit where it keeps the prompt. And you know, at some point I'm gonna go look at the API documentation and figure out there's a way to just easily clear that. Anyway, so this is interesting. Like this, it didn't say hi back. It just gave me a period. But anyway, the response is whatever. But now I can ask it what's my name? What's my name? And it has no idea, right? Because we haven't built in the history. So let's get into that. So now we're going to go back to like we showed before with step 4. And if we are ahead, so if I get if you want me to try something else or do something different, we can always stop and do some different things. I'm not going to promise to know everything, but we'll certainly try whatever we want to try. So now in step 4, we added some complexity here. So we'll uncomment that and take a look. Oh, we got a rate limit error. Okay. Please check your plan. Ah, okay. Yeah. I've had a paid account so long, Jeff, that I completely forgot. So there's this in chat about a rate limit. Yeah, there's definitely if you're going to be using the API, you get a free amount to play with for a little bit. But once you burn through that, you definitely will have to pay for at least when I last checked, which was a long time ago, to be honest. You have to pay for another version. But to your question, are these simple instructions to use other LLMs besides OpenAI, like Llama 3? Yes. And that's one of the benefits here is that it provides an abstraction from the model that you're using, so that you can swap out this code and use like LangChain. Let's from LangChain OpenAI. Like we have LangChain OpenAI installed, but there's like LangChain Llama, I think. Let me take a look real quick, actually. Did I spell llama right? I did. Okay, cool. There's this integration guides, right? I'm gonna post this if it's the right thing. Let me just take a peek real fast. Let me see if it doesn't have any code. But it's actually from Meta, so it's going to be talking about how to integrate theirs. I'm sure there's documentation in LangChain's documentation that I'm looking for, but there's definitely ways to do it. I'm just reading through some responses. There's certainly ways to add it. Right now we're using OpenAI. You can just essentially you swap this out, and then you change how you're connecting to it, you know, with the right key and setting up LLM. And that's why I called this LLM here instead of OpenAI or something like that. Yeah, so couple of key things. So one other thing I want to mention, Jeff, like if you do have any kind of paid API access, always protect your API key. That's why I say don't put it in code. You know, put it in a get ignore file. if someone has your API key, they can burn through your credits. Tip number 2, set a limit. I have a $20 limit on mine. I've never bumped into it, but it's $20 a month. If someone got a hold of my API key, the worst that they could do to me is $20 before I figured out something happened. So you can do that in at least in OpenAI's API, you can set a spending limit. Most modern tools allow for that kind of thing. So if there's an option for a spending limit, set the spending limit. The worst thing that can happen is it stops working on you and you have to increase it. And then the third thing is you may run into tools where I touched on the idea of agentic applications where you give it one prompt and it does its own thing for X number of future prompts. Auto GPT is an example of that. There's some other tools coming out like Morph AI and Devin AI. If you use a tool like that with your own API key, whether it's OpenAI or something else, there is a possibility of runaway. So whatever code you write, make sure you put in some limits. Anything that automates recursive calls like that to your API using your API key, you want to put in limits. Those are some good ways to mitigate your usage. And also, we were talking about this conversation buffer memory, right? Conversation buffer memory. I want to kind of undo what I said a little bit. Now that I'm thinking about it from this other vantage point. I said, you know, if you're doing a POC, maybe you don't worry about, you can send the whole history. But if you're working with a limited, you know, if you have a limited budget, and maybe you're doing a lot of testing with your POC, you might change this to conversation summary memory and reduce the token cost. And that's another way to keep from burning through your token limitations, your token budget, I should say. So yeah, thanks Vaughn for chiming in, and Amin also appreciate the help with the feedback. Okay, so here in step 4, we're adding oh, and the question about working with different LLMs, I would say absolutely I would absolutely say to look at LangChain's documentation, because there are other things that you can install other than LangChain OpenAI. If I had to just throw out a guess, I would say I could type pip install LangChain Llama 3 and it would install, it would exist and install that, and I could work with it. So look at the documentation though, better than just guessing and trial and error. And we may have a future class actually on how to implement other LLMs and do some more complex things too. Okay, so all of this is the same, except that we're now adding a conversation chain and a conversation buffer memory to the mix. And our code here is now still the same here, right? Where we're creating a prompt and, you know, setting up our LLM and our prompt on the screen. But the difference now is we're checking for a conversation. So this is what we went through before. I'm going to kind of skim over it a little bit and then show it. So if it doesn't exist, we create it, and we create it with these with this pattern here. And there's additional things that you can do here, if I recall. Maybe not on that one, maybe with the memory. Oh, I'm thinking of a different example. I tried several different ways of doing different examples for this, but in any case, here's where you can import a different memory type, like summary memory, and maybe we have some extra time, so maybe we'll try that in a second. But here's, you know, we're using conversation buffer memory here, and we're writing out a response to ST. So now the difference is we are taking input and writing this response, but we're doing it through our conversation. We'll see what that looks like here. Oh yeah, I don't have to rerun that because it's Streamlit. So did I comment that? I did. And it autosave. Cool. So it reran on its own. So we can just dive right in and say, so now I'm gonna give it different information. I'm gonna say I have 2 dogs. One is named Jax. Okay. So now my dog barked right as I typed that. Okay, so now we have no history, right? This is the first request, and we have a response. That's great. Dogs are great companions. What breed is Jax? Oh, it's asking me about Jax's breed. Okay. Oh no, I'm gonna have to live spell Chihuahua. I think I got it. Okay, so I tell a little bit more about my dog and all that, right? But now I'm gonna come back and I'm gonna say like I don't know, I'll say like I like sushi. And then I'm gonna say oh, it asked me about some stuff and I kind of ignored it. Do you have any other pets? And I told it about sushi and it got confused. Anyway, I'm gonna ask it, do you know my dog's names? I'm gonna ask it what you know about me. Sometimes it'll still get confused, but sometimes it works fine. So I ask it, what do you know about my dogs? And it's like, here it says, and I'm, by the way, I'm just outputting the raw response. It is simpler to view if you kind of separate the history out. Like my request and my response are split by this history, which is kind of a weird format, but it's, so we have to just remember to jump down here to read what it read, what it wrote back. So I ask it what it knows about my dogs, and it says, I only know what you told me. They're both Terrier Chihuahua mixes, which isn't actually true. But the one's named Jax, and it doesn't know the other name. It thinks Jax is 4 years old for some reason. So here's ChatGPT hallucinating, or sorry, OpenAI hallucinating a little bit. In any case, what we can glean from this though is that it does remember that the dog's name is Jack. So it's getting some extra information from I don't know where, but it is remembering the history that I'm asking for. And if I ask, what is my name? It doesn't know that. Did I ever tell it my name? Oh, no, I didn't. I just told it I have 2 dogs. No, whoops. So anyway, you can kind of see how this works, right? I tell it my name and then I can ask again, what's my name? And it's going to say, oh, it's actually confused because it didn't know my name the first time. So this is interesting how, and maybe a case for limiting the history, I guess. Yeah, some fake news. This is an interesting, unexpected response here, where it thinks it doesn't know my name, but let's refresh the context, right? So now I can say uh, uh, I'll just start with that, right? And then I'll say try it again. So it had the history of not knowing my name, which is where it got confused, which is interesting and maybe something to report back to LangChain, even that I don't know how we solve for that necessarily, but anyway, so I'll ask it what's my name, and it knows my name because that's the only history it has about my name in that case. So that's an example of what happens when we add the history. And if we look closely, So if I ask about my dog's name here, it's not going to know because I didn't tell it. This is a brand new session. As you can see, the history here only has my one request because I refreshed the page. But if I say, let me give it like three facts, right? Let me just give it a little information for context. So I'll give it something to have in the history, right? It's gonna, okay, it didn't ask me about anything cool. Just says that's interesting. So if I ask it to tell me about Jax, this is a more practical use of this, right? Where maybe not with dogs, but where you say, like with Google, you can say, remember that I have to do this or whatever. Remember that my favorite number is 42. And then you can actually ask it later. And it's kind of loose. It's not AI related or anything like that. But here, you can actually give it a bunch of things and then reference back and say, like let's say you meet someone new and you say, I met Jim Smith today and he has two kids and one of them's in college and he really likes golfing. So that might be a good suggestion for a sales outing with him to talk to him about products we offer. Then you could reference back to that kind of thing and be like, hey, tell me about Jim Smith. I want to set up a meeting for next week, and it might suggest golf, right? So if I say like, tell me about Jax in the context of our history, hopefully it will know I'm talking about my dog. Jax is, so it thinks it's a Jack Russell Terrier. He's 8 years old. It's making up a whole bunch of information now. What's interesting is most of this is kind of true. Crazy. Yeah, so it made up a bunch of weird information. So yeah, OpenAI is going to kind of make up some things, I guess, which is really hallucinogenic here. But we do have some history, right? Like it knows when I say Jackson, I'm talking about my dog. And I think with some better guardrails, we can have some better responses from it. And the more you chat, the more context it has too. So, all right. So that was the end of that bit of code, right? Before I move out of the code, do we have any additional questions related to the code or how any of this stuff works? And I'll give you a hint, like the next things that we'll look at is really kind of like we'll talk briefly about what we do next and have a little bit of space for additional questions. There's only a few slides left, so otherwise we'll finish a little early today. Okay. If you're typing, we can always come back to. So continue typing. Okay, let's go back to our slides. Not that one. Let's close that. Let's go back to our slides where it is. Give me 1 second. Let me find it here. I may have closed my slide deck window, which would be unfortunate. Where's... No, it's right there. Okay, there we go. Macs can sometimes be a little weird with that, with Zoom. Okay, so what's next? Well, I would suggest learning more about LangChain. Like we said in an earlier slide near the beginning, there's a lot of other things you can do, like building an agentic application. That was one of the early things that I've done a couple of times with an API. I built actually, it's funny that Vaughn mentioned fake news. I built a fake news like parody site that used OpenAI's API to make a call to the API to come up with an idea for a news story, a fake news title, a parody news article title, and then made another call to generate the copy for it, and did some things like that. And then there's, another, I did that just kind of as to see what I could do, right? Sometimes you build something that's not super useful, but just to learn the tools. And I built another one that you can tell it, hey, build a calculator app, and it made additional calls to come up with features and stories and document them in Markdown format and store them for me. It didn't write all the code. I didn't get that far, but those are the kinds of things that you can do with something like an agentic application that you can build. We may do a class. If it doesn't get too complex or into the weeds, we may do a class on that too in the near future here. But look at LangChain, look at their documentation, and just get to know it a little bit more and figure out what else it can do and how to work with other LLMs and models, which is the next thing here. Experiment with other LLMs and models and get a good idea for how to integrate other things. You can, in theory, not in theory, but probably in practice, I guess, you can set up your application to use LangChain to connect to multiple models and do comparisons, for example. Maybe you want to do a chat history comparison after seeing what we saw today with some hallucination. Maybe you want to use Meta's model and have Streamlit handle the input and output, but take that same input and send it to two different models. You could do that, do some kind of hallucination benchmarking. That might be something I might do this weekend, actually. Get into some of these other models and maybe do a hallucination benchmark and see which ones are crazier than other ones. So you can do all sorts of things. Get into the documentation, learn a little bit more how what LangChain does, how to use it with other models. Try some of those other memory patterns. Maybe output token outputs and see what you're getting token count wise with different memory models. Some of that work's already, most of that work's already done for you in that Pinecone article, but getting into the weeds a little bit yourself is a really great way to learn some of these things further. I've already asked a few times for questions related to code and specific things that we were in at the time. Do we have any general questions? Anything that you didn't get a chance to ask before? And feel free to come off mute or to pop it into chat, either way. Is LangChain production ready? That's a great question, and I've seen people say that no, it's not production ready. I don't know specifically if that's 100% true or if that was true at some point and not anymore. I would say I have some level of comfort, but it kind of goes back again to the use case of what you're doing with it. So some of the things that I would use it for in production, at least at this stage in my use of it, would be perhaps production ready for me, where the risk is lower, right? If you're talking about enterprise and much higher risk, then the production readiness of it may be a little bit more objectively untrue. Like you may not feel it's production ready for you. But I don't really have a great answer to that, to be honest. I would again suggest looking at the documentation a little bit more. I know some people are doing some pretty cool things with it, and some people are using it in production, I believe. But they also have a Slack space, and I believe a Discord, unless I made that up. I might be hallucinating now too, but they may have a Discord too. Reach out and look through the documentation, and you'll be able to get a better idea that way. It's a really great question, though. I have seen that question before. I didn't dig in too much prior to this, to be honest. Okay, so I do have one more slide here, and with Vaughn's help, we'll share out some of these. Vaughn is on top of it. I barely got the words out of my mouth. Thanks, Vaughn. Thanks to Vaughn, we have some of the links from earlier in the class, as well as some additional links here. I'd love to stay connected with everyone. In addition to the events link there, that will give you some future IntegrateDetroit events and integral webinars where we talk about some additional topics. We have our website, our YouTube, our LinkedIn, where we can connect there, and my personal LinkedIn as well, if you want to connect with me. And I see Jeff has an idea for a future class. I love the feedback. If there's something, and we'll have a survey going out as well. I'll send an email out that has a survey in the slide deck. But if there's anything that I can improve, if there's something that I did great, tell me. If there's something that, and tell my boss, if there's something that I did that I could do better, that I've missed or whatever, better presentation, other ideas, like Jeff says, definitely share them. I'm always open to feedback. I think it would be interesting to have a class to learn how to fine tune a transformer general language model for custom data. That's a great idea, Jeff. And actually, I know someone who may be lining up to do something like that. I think he's getting ready to do a blog on it, a blog post for us on it. And maybe I can convince him to do a class too. So that's a wonderful idea. I love it. Then this other one, we can look at into DSPY. I'm not familiar with DSPY. Maybe we can cover RAG fine tuning. Yeah, that would be good. And we do have an article, I think, on that also on the website. So in the links list above, if you look at the website link, integral.io, we have some blog articles there, and I believe there is one on fine tuning, RAG fine tuning as well. Or sorry, RAG versus fine tuning. Okay. Yeah, look through what we have there. We also, I'm definitely taking these ideas down for future stuff as well. And let's see. So what is DSPY? And I'll be honest, like sometimes I'll see something, I'll just forget about it. Programming, not prompting, foundation models. Okay. Framework for algorithmically optimizing LM prompts and weights. Yeah, okay. Yeah, there's a lot of talk about prompting, right? Prompt engineering, becoming a prompt engineer and making $1 billion, like all those things. And there's definitely something to look at there. DSPY certainly seems like something I'd like to experiment. So if I dig into that deep enough to form a class around it, or a webinar or a blog article, then I'll share that out as well. Yeah, and I see Vaughn posting that link out. Thanks, Vaughn, to that blog article. I believe that was from Nate. I think Nate wrote that article, and Nate and I kind of went deep on some topics. We ended up building the first custom ChatGPT clone around OpenAI's API for our internal use that we ended up before LangChain having to use Pinecone and VectorDB and all that. Nate's an incredibly smart guy. Yeah, models working with custom data. One of the next things that I forgot to mention this, right? So I'm glad you brought it up, Patrick. Thank you for that. One of the things that I wanted to mention as part of this class is not only can you use LangChain with all these other models, but I believe there's tooling in place that you can use it for a local model as well. So you can have your own custom model or local model and bring that in so that you have a little bit more confidence about what you're putting into your chat conversation and the safety of it and security and privacy of it. And that's something that I want to go into in a future class potentially as well. And then I see Kieran has a question, which I think is maybe something for Amin about the DSPY.
Yeah, like I don't know much about the SPY. I just I think like read like went across this like repo in GitHub. I'm interested. Yeah, like I was like curious like whether like you guys know about it. But I'll like read about it. Like maybe I can share some stuff next time.
Yeah, I haven't I haven't looked at that so much, but it looks like they have a collab too where if you're familiar with Google Colab, it's an easy way to just without setting anything up locally try things out. So that might be a good way to poke around it and see what it does. Sometimes the documentation is really useful on a project, and sometimes it's easier to just open it up and start playing with it and just see what it's doing. Which is why I did, here I did the code and then also kind of walked through running the code so we could see it in action. But yeah, it looks cool. I think it also, just at a glance, seems like one of those tools that could be incredibly useful. And then there's also potentially use cases where it's a bit of overkill and not necessary. But I think in a lot of cases, from just at a glance at what I'm seeing here, it looks like it would be it could be potentially really useful. And also, of course, depending on how it works too. So that is all I have for today. I invite everyone to connect with us on future events through Eventbrite or hit up our website and see some of the blog posts and other things that we have going on there. And also hit me up on LinkedIn and let's connect. I'm available to answer questions. I'll try and respond on LinkedIn if I can be better about logging into LinkedIn. But yeah, I'd love to stay connected. We'll do more classes like this, and I'll be I think swapping roles with Vaughn next month on a class that he'll be doing, and I'll be assisting. So I'll give everyone about 20 minutes back. Looks like we'll finish up a little bit early today. Feel free to connect with me if you have any future questions, and we'll see you in the next class. Thanks everyone for joining. I know it's hard to take part of a Saturday morning out, especially if it's nice out wherever you're at. So it's really good to see people here. Appreciate y'all.
Yeah, thank you.